Welcome to Module 2.3, where we'll take a deep dive into decentralized exchanges, or DEXs, and take a closer look at their mechanisms. Centralized exchanges serve as intermediaries, matching buyers and sellers to facilitate crypto trades on a centralized platform that also stores users' funds. DEXs, however, operate differently. A DEX typically facilitates trades directly between users' wallets using smart contracts, allowing users to maintain their own private keys without the need to trust third parties. There are various types of DEX, but in this module, we'll examine order book DEX, automated market makers, and hybrid DEXs in detail. The first category, order book DEX, operates similarly to centralized exchanges by matching buyers and sellers via peer-to-peer order books. But unlike their centralized counterparts, order book DEX don't rely on centralized platforms, and users have custody of their own funds. Within this category, there are two subtypes: on-chain and off-chain order book DEX. On-chain order book DEX arguably offer the highest level of transparency and decentralization, as the process of matching trades and trade settlement all take place on-chain. However, this approach can be impractical because adding orders to the blockchain can be cumbersome, slow, and costly. Off-chain order book DEXs have some trading activities off-chain with trade settlement occurring on-chain to lower cost while increasing the speed of transactions. Although more centralized than on-chain order book DEX, these platforms allow users to enjoy the benefits of decentralization and traditional trading. Another type of DEX is the automated market maker, or AMM. Rather than utilizing order books, automated market makers enable automatic crypto trading through liquidity pools and smart contracts. If we consider trades on order book DEXs as peer-to-peer, then trades on automated market maker can be described as peer-to-contract. AMMs don't require counterparties as trades are executed between users and smart contracts. In the absence of order books, AMMs generally don't have order types. The price you receive for an asset you buy or sell is determined by a pricing algorithm. These algorithms are intricate, but let's have an overview of one of the most basic pricing algorithms. AMMs rely on liquidity pools. These pools are reservoirs of assets managed by smart contracts that traders can trade against. The users who provide funds or liquidity to these pools are referred to as liquidity providers, or LPs. Why would LPs want to add liquidity to the liquidity pool? Adding liquidity to these pools can be lucrative to LPs who can earn fees from the trades that take place in the pool. For example, LPs can deposit an equivalent value of two tokens, let's say 50% Ether and 50% DAI, to Uniswap's Ether DAI pool. Traders using the Uniswap liquidity pool to exchange tokens need to pay a fee. This fee is then divided among the LPs, with each LP receiving a share proportional to their contribution to the liquidity pool. But how are trading prices determined? Let's stick to the Ether DAI example. We'll call the Ether portion of the pool X and the DAI portion Y. Uniswap takes these two values and multiplies them to calculate the total liquidity in the pool. Let's call this K. In other words, X multiplied by Y equals K. The core idea behind liquidity pools is that K must remain constant. When Alice buys 1 Ether for 1,000 DAI using the Ether DAI liquidity pool, she increases the DAI portion of the pool and decreases the Ether portion of the pool. This means the price of Ether goes up in order to keep K constant. The reverse is true for DAI. Essentially, the price is determined by how much a given trade shifts the ratio between X and Y. It's worth noting that this model doesn't scale linearly. The larger the order, the more it shifts the balance between X and Y. Larger orders become exponentially more expensive compared to smaller orders and lead to larger amounts of slippage, which refers to the difference between the expected price of a trade and the price at which the trade is executed. The way the pricing algorithms work also means the larger a liquidity pool is, the easier it is to process large orders because the shift between X and Y is smaller. Here's an intriguing thought experiment that can help illustrate why this model can't scale linearly. Consider whether it's possible to purchase all Ether in the pool. The answer is no. While you could pay an increasingly high premium for each additional Ether, you could never acquire all of it. Recall the formula: X multiplied by Y equals K. If either X or Y equals 0, this equation is no longer mathematically viable. Now that we've explored AMMs and order book DEX, let's look at hybrid DEX, which aim to merge the benefits from both centralized exchanges and DEX. They generally use a mix of AMMs and order books to operate and seek to provide the functionality and liquidity of a centralized exchange with the privacy and security of a DEX, giving users more control and flexibility. DEXs offer several advantages over centralized exchanges, including greater privacy, full control of funds by users, and increased transparency due to on-chain transactions. However, they have downsides too. DEX typically have lower liquidity and trading volumes, and their user interfaces can be complex, making them less friendly for beginners. Additionally, transaction times and costs are subject to network congestion, and there's no customer support in case of issues. Given their decentralized nature, DEXs could also potentially face complex legal challenges and scrutiny. The world of DEX is evolving rapidly. There are many DEX allowing users to provide liquidity in measures other than the 1-to-1 ratio in our example. Other DEX allow users to provide liquidity with just one or multiple cryptocurrencies instead of having to use a pair of cryptos. Many DEX constantly release updates, and the information in this lesson is subject to changes. In the next module, we'll learn how to buy and sell crypto using different types of exchanges.